Hi guys. This video is going to cover probability distributions for continuous random variables, and I'm going to do it in a way that follows section 7.3 of the textbook Introduction to Statistics and Data Analysis by Peck, Olson, and DeVore. So I'm going to follow along with that. It's going to be a pretty easy discussion. No calculus and not even much mathematics as it happens. We're just going to go through definitions and make sure we understand the ideas. First thing I want to do is make sure that we have a clear idea of what a continuous random variable is. So I want you to imagine that we're studying, let's say, the birth weights of some interesting animal. We might find that the animal that we're studying has an average or mean birth weight of 5 pounds. That would mean that birth weights vary. If there's a birth tomorrow, it could be less than 5 pounds or more than 5 pounds. But on average, they tend to be around 5 pounds. Let's say even further that we have a standard deviation. We'll make it 1 pound for our example. And you may also realize that birth weights are normally distributed. So I'm going to make a normal distribution. We're going to come back to this later and look at it a little bit more carefully. But let's draw a picture and just make sure that we're all really well versed in what it is that we're talking about. So we have a mean of 5 pounds for this animal at birth. That means that most animals are around 5 pounds at birth. Some of them tend to be a little bit higher, some tend to be a little bit lower. A few tend to be very much higher or very much lower, but in general, they tend to be clustered around the average, which isn't that surprising. It's fairly easy to accept that as an idea. Well, that's a continuous random variable because birth weights can take on any value on the number line. They are not discrete values. If one animal is born and it weighs 5 pounds and the next animal's heavier, it might weigh 5.1 pounds. It isn't automatically obligated to weigh 6 pounds if it weighs just slightly more. That would be discrete data. This is continuous data. So within our range, the birth weights or any random variables can take on any value within the permitted range. So it's a continuous bit of data, and it's a random variable because each time it occurs, it's random. Today, the animal was 5 pounds at birth. Tomorrow, it'll be 4 pounds. And the day after that, it'll be 6.2 pounds. We don't know. It has an element of randomness. This forms a probability distribution when we treat it as a resource for answering probability questions, like this. Let's say, and I'm just going to draw on something you probably remember, that we can use the empirical rule for this. Let's say that we are asked the question, what is the probability that if we randomly selected animals from this population at birth, that they would be between 4 and 6 pounds? And that would be, we could write it this way. That would be something that we could answer using the empirical rule. And I'm going to go ahead and answer it in a second. But what I want to do is really highlight what I just did, what we just did. And that is, we took this knowledge of the distribution of the data that we're studying, the birth weights of these animals at birth, and we turned it into something that was a resource for answering a probability question. So we're no longer talking about, for example, the proportion of these animals at birth that are between 4 and 6 pounds, but rather the probability that a randomly selected birth would result in an animal between 4 and 6 pounds. It's almost the same thing, but it's not quite the same thing, because when we're doing probability, we're talking about not the proportion of the population, but rather the proportion of some event. Real clearly, what is the proportion of births that occur that result in an animal between 4 and 6 pounds in our theoretical population? The good news is we can answer it in exactly the same way using the empirical rule as we might have done other questions that aren't based on probability. So we know from the empirical rule that, for example, just about, not exactly, but very close to 68% of a normally distributed distribution will be found within one standard deviation of the mean, according to the empirical rule. So that would be our answer. The probability that we would randomly select a birth that resulted in an animal between 4 and 6 pounds would be 68%.